Good morning, friends. I am here for my course, Engineering Thermodynamics. I am Dr. Dwivedi, Professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. I am in the process of delivering my lecture for Engineering Thermodynamics for BTech Aeronautical and the Mechanical students. Today I am in the discussion on question bank module 2, that is second law of thermodynamics, which I will be taking in this course. So I will go with the question number 1. So what is the question? Explain the limitation of first law of thermodynamics in detail. So we have to see, we have seen in the previous lecture and that what is the first law of thermodynamics. The first law of thermodynamics state about the conservation of energy. So in this we have some limitations because we cannot convert all heat which you are supplying to the system to the work. There is some losses, and these losses are explained in the second law of thermodynamics. So there are some limitations of the first law of thermodynamics that we are going to discuss in this question. The limitation of the first law of thermodynamics is that it does not say anything about the direction of the flow of the heat. So it will go from the surrounding to the system or the system to the surrounding. It doesn't say about that. It does not say anything whether the process is a spontaneous process or not. The spontaneous process is the process in which it is a natural process from high temperature to the low temperature. Heat will always transfer from high energy level to the low energy level. But the first law of thermodynamics do not say about that. It says that dQ is equal to dW. So it doesn't say that how much dQ will be converted to the dW or how much if you supply the dW work, it will be created as a heat. It doesn't say about that. The reverse process is not possible. We know that if we cannot get exactly the reversible process. It doesn't say about that also. In actual practice, the heat doesn't convert completely into the work. We have seen that if you rub like this, we are getting some heat in our hand. But how much we are spending the work, how much percentage it is converted, it is not known. And if it would have been possible to convert the whole heat into the work, then we could drive the ship across the ocean by extracting heat from the water of the ocean. So if it is possible that all the energy can be converted to the work, all the work is into energy or heat, then if you sail the ship will be continuously sailing without spending any energy, and it will extract energy from the water of the ocean and it will be sailing. So, but it is not possible as per the second law of thermodynamics. So, first law do not say about the direction, and these points are the gray point where our first law of thermodynamics is not say about these points. Now, explain the heat pump with a neat sketch. So, just I will be discussing about the heat pump. So, a heat pump is a part of a home heating and the cooling system and is installed outside the home. Like an air conditioner, such as the central air, it can cool your home, but it also capable of providing heat. So, it can cool also, it can heat also. That is called the heat pump, and it is reverse of the engine. In cooler month, a heat pump pulls heat from the cold outdoor air and transfers it to the indoor, and in warmer month, it pulls heat out of the indoor air to cool your home. So in a hot season, it will extract heat from your room and it will send outside. In the winter season, it will take heat from the atmosphere and it will give you the heat in the room. So it can be used for either cases. They are powered by electricity and the transfer heat using refrigerant to provide comfort all year round. Because they handle both cooling and the heating, homeowners may not need to install separate system to heat their home. So in the Western countries where we have the very cold, your heat pumps are very much required. It can be used for maintaining the high temperature also. In cooler climate, an electric heat strip can be added to the indoor fan coil for additional capability. Heat pumps do not burn fossil fuel like furnaces do, making them more environmental friendly. So they don't use the petrol and diesel, and so it is very, very environmental, and it is a very eco-friendly system. Now the question 3, give the Kelvin-Planck statement and explain with an example. So we will discuss about second law of thermodynamics, which is explained by the KP statement. That is called Kelvin and the Planck statement. Kelvin-Planck second law of thermodynamics states that practically a reservoir never gives a positive net amount of work from the heat extracted from a thermal reservoir. So basically you cannot have a heat engine that operates between the two temperature levels and it has no heat rejection. So the meaning of this thing is we need one high temperature source and one is a low temperature sink. Then only it is possible to get the work done. So Kelvin-Planck statement example, a Russian chemist and the philosopher named Friedrich Wilhelm Ostwald introduced a theoretical concept of the perpetual motion machine of the second kind, abbreviated as a PMM2, and this device could perform work solely by absorbing heat from the body. Such a device completely follows the first law of thermodynamics. However, Kelvin-Planck statement states that practically we cannot construct the perpetual motion machine of such type of things. Now if we talk about another statement, it is called the Clausius statement and explained with refrigerator as an example. Heat will always flow spontaneously from hotter substance to the colder one. So if it is a spontaneous process, it is a natural process. Spontaneous means natural, and this natural process will only happen when the heat is going from higher side to the lower side, high temperature to the low temperature. It is a spontaneous, but you cannot make from low temperature to high temperature. Explaining that why an ice cube will melt when placed in a bowl or a hot water, but ice will not form from water outside on a hot day. So ice can be converted to the water, but water cannot convert to ice in a normal. You have to do in some additional process. Everyday experience certainly supports this statement, but it is a deep physical concept limiting what possible with the energy. So if you see here, we have all real refrigerator requires work to get heat to flow from a cold area to a warmer area. So here if you see, if you want to make a refrigerator and you want to extract heat from this cold reservoir, so if you want to extract this thing, you need some work done. So work has to come from this side, this has to come, and it has to be rejected in a hot reservoir. So this is the process which is possible. If you see here, the cold reservoir to hot reservoir, this is not possible. Second law of thermodynamics violates here. This type of is not possible, and if you want to do, you have to add here work. If you are able to do this adding the work, then only this is possible. So this is the Clausius statement, and these Clausius statements are used for the refrigeration and air conditioning and the heat pump. This Clausius statement is used, and the Kelvin and the Planck statement is used for the engine, in which work will only happen if the rejection of heat is taking place. If there is no rejection of heat, the work will not be done, and KP statement we will be violating. Now I will talk about the state PMM1 and the PMM2, that is the perpetual motion machine of first kind and the perpetual motion machine of the second kind, in which manner both are different. So this is the question. So we will see the answer that perpetual motion machine of first kind, a machine that produces work continuously without any energy input. That is the perpetual motion machine. Without any energy, it will continuously working. Such machines violate the first law of thermodynamics. PMM of the second kind, a machine that can generate work from a single heat reservoir, that is only one reservoir source, and as a result have 100% thermodynamic efficiency. So that is your perpetual motion machine of second kind, that only by the one reservoir, that is the heat source only, it will work. Heat will not be rejected. Same heat will be circulating again and again. Such devices violates the second law of thermodynamics. So here we can see the perpetual motion machine of the first kind. So here it will be always giving the work without taking any input. Okay, so it is a machine which will be always working without taking any work. And if you see here, perpetual motion machine of the second kind, this is only the source is required and it will give the work. So 100%, here the efficiency will be 100%, no rejection of heat. No rejection of heat. So that is the perpetual motion machine of second kind. Now I will discuss about Carnot principle. What is the importance of the principle explained? So after this Kelvin and Planck statement and the classes statement, the Carnot has discussed his own principle, and it is told that as per his definition, only this is the highest efficient system which he has given. So Carnot theorem, also known as the Carnot rule or the Carnot principle, can be stated as follows. No heat engine operating between two heat reservoirs can be more efficient than a reversible heat engine operating between the same two reservoirs. So if you have the two reservoirs, one is the heat source, another is the heat sink, and the temperature TH and the TL are fixed. So the Carnot has told that between the given condition, there you cannot produce more efficient engine than the reversible heat engine. Means all the processes are the reversible processes. That is the reversible compression, reversible adiabatic expansion, then reversible isothermal heat addition, and reversible isothermal heat rejection. If you have all the reversible processes, then it will give the maximum efficiency. And that is also maximum efficiency is not 100%. No one can produce any efficiency more than 100%. And he has calculated that as per his concept, for a given temperature of the source and the sink, that is TH and the TL, the maximum efficiency can be achieved only by the reversible cycle processes. So in this diagram, if you see, here we have the TH, it is a high temperature, it is a source. From here we are extracting the heat QH. Work is done W and some heat is rejected. So we can see that this W is equal to difference between QH minus QL. And this is the definition of the Carnot principle, and he has told that maximum efficiency can be only achieved by the reversible heat engine. This is now question number 6. Define Gibbs-Helmholtz function, write Maxwell relations. So here we will see that the Gibbs-Helmholtz equation is a thermodynamic equation used for calculating changes in the Gibbs free energy of a system as a function of temperature. It was originally presented in 1882 paper entitled by Hermann von Helmholtz. The application of the Gibbs-Helmholtz equations are as follows. In the calculation of the temperature change effect on the equilibrium constant, in the calculation of enthalpy change for a reaction when the temperature is not 290 Kelvin. So these are the application for the Helmholtz, Gibbs-Helmholtz functions. Now we will discuss about Carnot cycle. Illustrate the Carnot cycle with PV and the TS diagram. So we will see here that PV diagram of a Carnot cycle, the area bounded by the complete cycle path represents the total work done during the one cycle. The Carnot cycle is often plotted on a PV diagram and the TS diagram. So just I am explaining here what is the PV diagram and what is the. So here we have the 1 to 2 is a reversible adiabatic compression. 2 to 3 is isothermal reversible isothermal process. Here heat is added. Again from 3 to 4 is a reversible adiabatic process where Q is equal to 0. We are not adding and subtracting. And the 4 to 1 is the heat rejection in a reversible isothermal process. So if you draw the TS diagram here, TS, so 1 to 2, from here 1 to 2, it is a constant entropy, that is one process, that is compression. 2 to 3, then 3 to 4, and 4 to 1. So this is the, here 1 to 2 is isentropic compression, 2 to 3 reversible isothermal process, 3 to 4 isentropic expansion, 4 to 1 is isothermal heat rejection, and this all are the reversible. All processes are reversible. So this is the PV and the TS diagram, and this gives the highest efficiency. If any engine we are constructing and which gives more than this efficiency, it means there is some problem and we have to relook on that. Explain the principle of entropy increase. Entropy is chaotic situation. It is not the ideal, and it will generate the inefficiency. The efficiency will be reduced by the generation of the entropy. The increase in entropy principle states that for any process, the total change in entropy of a system together with its surrounding, adiabatic surrounding, is always greater than or equal to 0. So this delta S will be equal to or greater than 0. It never be negative. Thus, total change of entropy is denoted by the entropy generated during the process, and it is mentioned as Sgen, kilojoule per Kelvin, and it is denoted as a Sgen. So here we can see here that the process here 1 to 2 and the 2 to 1. So here del Q by T is equal to process. Here 1 to 2 and then 2 to 1 del Q by T, and del Q pi it is less than 0. So here we can find out that delta S is equal to S2 minus S1. It is greater than 1 to 2 del Q by del T. So it is always delta S will be greater than or equal to 0. Now I will go for the next question. What is irreversibility, and explain. The quantity of being irreversible, the quality of being irreversible, once done, it cannot be changed. So antonyms of this is reversibility, the quality of being reversible in either direction, type of It is changelessness, unchangeability, changiness, and unchanginess. Irreversibility is a state in early child development in which a child falsely believes that action cannot be reversed or undone. Examples are: in a 3-year-old boy sees someone flatten a ball of play duff. He will not understand that the duff can easily be reformed to its ball. Okay, so that is the example. Okay, I think so. In this next, we will be discussing about this, and these are my references. So about Eunice Senegal, Michael A. Bors, Thermodynamics and Engineering Approach, Tata McGraw-Hill's. Another one is the NPTEL lecture of Engineering Thermodynamics by Mishra IIT, Kanpur. Any questions you are welcome to ask in my email. You can send ydwedi@gmail.com. Thank you very much. Please do like and subscribe my channel. Till then, please be tuned for my next lecture. Next lecture is related to the power cycle of the thermodynamics.
Like, share and subscribe. Hit the bell icon for more updates.